Okay, in section 12.3 we're going to be talking about measures of dispersion, or we also call measures of spread. In the last section we talked about measures of central tendency, talked about the middle of the data. Now we're going to talk about how the data is spread out. So the first thing we're going to calculate when we're given a data set is the range. And ultimately we're just going to describe the range as the highest data value minus the lowest data value. So for instance, if we had Honolulu's hottest day as 89 degrees, coldest day as 61 degrees, the range in temperature is 28 degrees. Key thing to notice here is that the range is a number. Okay? It's one number. The range is not 61 to 89 or something like that. That is not the range. The range is the difference, okay, between the high and the low, whatever those two numbers may be. Okay? Now, more importantly for our future use, we're going to be calculating what we call deviations. Okay? So the first thing I want to look at is we're going to be given 5 data items here, and these might represent whatever. It doesn't really matter what they represent in this particular case, but bottom line is if we want to find the deviations from the mean for these 5 data items, we have to do a couple things. The first thing we have to do is we have to find the mean. Okay? So this actually does come from something useful here. This is the countries with the most workers, 5 different countries that we're choosing from here. And so we're going to calculate the mean, we'll add them up and divide by 5, we get 317. Okay. Now, each one of these data items is going to have a deviation from the mean. Okay, and that deviation is going to be the data item minus the mean. So in other words, how far apart are the actual points from the mean? So with that said, if we take the first data point, we do 778 minus the mean, we get 461. So its deviation from the mean is 461. Okay. We could go on further to calculate the other deviations with the 472, etc. Okay. Keeping in mind that if we did the 147 okay, for the US, okay, we'd be negative 170. And a negative here, of course, just indicates that it's on the other side of the mean, that it's less than the mean. Okay. Now, what we're going to actually use these deviations for is to calculate what we call the standard deviation for a given set. Now, the standard deviation is a fairly tedious thing to have to calculate here, but I'm going to go through the steps here and then we're going to learn how we're going to use it in this class. So we're going to find the mean. We're going to calculate the deviation of each data item like we did. We're going to take those numbers that we found and we're going to square them. Okay, and then we're going to add those all up. Okay, and then we're going to divide by n minus 1, where n is the number of data items. So in our case that would be 4 because there was 5 data items. And then with that said, we're going to take the square root of that quotient that we found in step 5, and this value is what we call the standard deviation. Okay, and what it boils down to is the larger the standard deviation, the more spread out the data is, okay, which we'll interpret in a few minutes. Now, in this case, once again, we found the mean earlier to be 317. Okay, we found the deviation for a couple of them. We need to find all of the deviations. Okay, generally the best case scenario is to find the deviations and put them in a chart like this. Put the data item, okay, calculate the deviations in one column, square the deviations. So whatever we get for the deviations, we're going to square them, and notice that they're always positive because we're squaring a negative, which gives us a positive even if they are negative. Okay, and then ultimately we're going to add these up. Okay. Now keep in mind that the sum of the deviations should always be 0. So if you want to check yourself as you go, if you add up the 5 deviations, you should get 0. And then when you add up the second column, the squares of the deviations, okay, you're going to get whatever this number is. Okay, this is going to be the sum of the deviations. So we're going to add those all up. Okay, and then from there, we're going to divide by n minus 1. And as I mentioned, n minus 1 in our case is 4. And we're going to get this number. Okay. And then with that said, we're going to take the square root and we're going to get 302.16. So ultimately the standard deviation is approximately 302.16 million workers. Now, that's a fairly large number, okay, which means this data is fairly spread out. You know, we're going from 772 down to 82, I believe I said. And so therefore the standard deviation is fairly large because the data is fairly spread out. Okay. Now, I'm also going to show you that this can be checked with your calculator. Okay. If we go to stat button, edit, and we type our data in there, I put it in here, 778, 472, 147, 106, 82, put those all in there as such. Okay, your calculator will actually calculate quite a bit of the data here. So we're going to go to stat again, calculate, we're going to do 1 var stats. Okay, and as long as your data is in list 1, then you can just hit enter. And notice there's the mean that we already talked about. We have the sum of all of the elements together. We have the sum of all the squares. Okay, and then this S of x is the standard deviation. And notice there's two numbers here that appear to be kind of close to each other, and they both have similar notation over here. We are always in this class going to be using the big S number, so this is our standard deviation. We are not going to use this for the time being. Okay, so when you're asked to find standard deviation, it should match up with what you have here. Okay, if you draw the arrow, notice here we can go n equals 5. Okay, we also have some other data down here, okay, which we'll not deal with in this particular section. Okay, key element though is that we have the mean and we have the standard deviation calculated for us if we put the numbers into the calculator correctly. Now, a little bit about why we would want to find the standard deviation or what it tells. I'm going to use your book as an example here in example 5. Okay, they give us a 5th grade class, nearly identical mean scores on an aptitude test. One class has a standard deviation that's 3 times that of the other. All the other factors being equal, which class is easier to teach and why? So with that said, ultimately we'd want a smaller standard deviation, because if there is less spread amongst the students in the classroom, okay, it's going to be easier to teach because they'll be ultimately closer to each other at ability level. If we have a class that has an ability level that is very high to very low, okay, that's going to end up being a more difficult class to teach. Similarly, in the stock example, we have small company stocks and large company stocks. The means here, the means 17.5 and 12.4. So clearly we'd make more money on the small company stocks because we get a better percentage. Okay, but the standard deviation is also higher, which ultimately means it's going to be riskier. Okay, there's going to be more higher and more lower, whereas this one they're going to be centered around closer to the mean, so they're going to be ultimately closer to one another than what these would be. So the more spread out they are, okay, the more risky the stock would be in this particular case. Okay, the closer they are together, the less risky.